Hello, you're welcome. We are now on question number 11. Now, this question shows a diagram of y equals a function of x. So they've plotted the graph already, and we have a point P being minus 2, 11. That's point P right here. We have our point P right there. Now, we're being told to find, we're being told that the tangent from P touches the graph y equals f of x at point AB. The values of a and b are integers. That's very important. So we need to unpack this. What's very important? The fact that they are integers. Okay, so let's unpack this statement. The tangent from P, that is, what's a tangent again? In the previous video, I told us that a tangent is a line that touches a circle or a curve at just one point. So it means you're going to draw a line starting at point P, and you need to make it touch this curve at just one point. Where is that point? It's going to touch it at point AB. And the values of A and B are integers. So you need to remind yourself, what is an integer? An integer is a positive or negative whole number. So you're going to draw a line from P that is going to touch this curve at just one point. That is what makes it a tangent. And this particular point is going to have a pair of coordinates, because you know it's on the grid. So it's going to be a pair of coordinates of x and y. Both of them must be integers. They must be positive or negative whole numbers. So we have been told that by drawing this tangent, we should find the value of A and B. So what do we need to do? Draw the tangent. You place your ruler neatly on the diagram in such a way that the line does not cut into the curve. What do I mean? You can't say you're drawing a tangent like this. You can't say this is a tangent. This is not a tangent. Why isn't it a tangent? Because the line is cutting the curve on two occasions, here and here. That's not what you want. This is not a tangent. This is just a line passing through the curve. So this is wrong. And you can't claim this is a tangent either. Okay, let me just leave that on the screen so that you can compare. So this isn't a tangent. Neither is this a tangent. Because this particular line, yes, it passes through point P, but it is not touching the curve anywhere. So it's not a tangent to the curve. Your tangent to the curve should pass through P and the curve at just one point. So I'm going to draw the tangent now. You should use a ruler. I'm trying to wing this. Yeah, I hope, oops, it didn't come out right. I'm going to do it again. Aha, there you have it. That is a tangent. Now, never mind, mine is resting too much on the curve, but when you are doing the work, you need to use a ruler and you should just touch the curve at one point. Now, if you take a close look at where my tangent is touching my curve, it will be right here. My tangent is touching my curve right here. That is where the point, or that is the exact location that my tangent is touching my curve here. Yes. Okay, so now I need to write down the coordinates of that point. Here is when you need to look closely at your graph and understand the scale of this particular graph. If you take a good look at this, you will notice that yes, 10 little boxes here make up 1, but on the x-axis, but on the y-axis, 10 little boxes make up 5. So that means 2 small boxes is 1. So that means if I'm going to count how many boxes this will be, 1, 2, 3, 4. So that means the value here is actually 2 and 1. So my x coordinate is 1, meaning A is 1, and my y coordinate is 2. I hope you understand that. Now we are being told the B part of the question. We're being told to find the equation of the tangent, giving your answer in the form y equals to mx plus c. Now, the equation of the tangent, or the equation of any line in the form y equals mx plus c, just a quick reminder, means that this m is your gradient and the c is your y-intercept. So those are the two things you need to write the equation of this line. So first and foremost, we need to find the gradient. How do we find the gradient? Gradient is given by rise over run. Changing y, that is y2 minus y1 over x2 minus x1. Now, the beautiful thing about this particular question is that we already have 2 pairs of coordinates. Originally in the question, we were told that point P is minus 2, 11. So that's a pair of points. We have minus 2, 11. And our tangent is also a pair of points on the line. It's what? 1, 2. So those are 2 points on our line. What we now need to do is to identify the one we want to choose as our 1 and the one we want to choose as our 2. So this first one here, I'll choose it as x1, y1. And this will be x2, y2. Why do I label them? Because they're numbers and sometimes they look so similar. So to stop myself from making the mistake of mixing up the numbers, I label them. I'll advise you do same. So we have labeled now. Our y2 is 2. Our y1 is 11. So it's 2 minus 11 over x2 is 1 and x1 is minus 2. So minus 2. And this gives us 2 minus 11 is minus 9, and 1 minus minus 2 is 3. So this gives us a gradient of minus 3. So we know our gradient is minus 3. M is equal to minus 3. Now we need to find our C. Now, if you look at your diagram closely, you will notice that you can actually see C. What is C again? C is your y-intercept, where the line cuts the y-axis. Our line here cuts the y-axis right here. So what is our C? It's 5. Therefore, the equation of this line in the form y equals mx plus c will be y equals, what's our m? Minus 3x plus c. Our c is 5. So our equation is y equals minus 3x plus 5. That's it. We're done. Thank you so much for watching, and see you in the next video, where we will be talking about cumulative frequency diagrams. Bye.